All right, so this is part 3 of section 1.2. We're on the second page of notes, and in this section, I'm going to be showing you how to find the least common multiple. So the least common multiple is the smallest common multiple of 2 or more whole numbers. And we start off finding the least common multiple the same way we found the greatest common factor, by factoring our numbers and writing them out as their product of primes. So here in this question, we have 60 and we have 72. So let's factor 60. I'm going to say for this one, well, 60 ends in a 0, so I know that 10 goes into 60. So I'm going to start off by taking a 10 out. And then I'm left with 6. And for my 10, I'm going to break it into 2 and 5. And my 6, I'm going to break into 2 and 3. And if you didn't want to do it this way, instead you wanted to start off by taking a 2 out because it's even, that's fine. Remember, there's multiple ways of doing your factoring. So our prime numbers here are 2, 5, 2, 3. And for 60, I have 1 2 and 2 2's, so 2 to the 2 times 3 times 5. Remember, it doesn't matter the order these are in the factor tree. I want to write them from the smallest one on the left, okay, to the largest on the right, smallest to largest. And then I have 72. So 72, I have 2 and 36. And then, hey, 36, I know that splits into 6 and 6. So 6 can be 2 and 3 and 2 and 3. So these are my prime numbers. I'm going to highlight them so they're easy to read. So 72, my lowest number is 2. So I have 1, 2, 3. 2 to the 3, and 3 I have 2, 3 to the 2. All right, so now, so far that was the same. Now we're getting, so that's step 1, write each number as a product of prime factors. So we've done that. This next step is different. Select all the different prime numbers. So here I'm looking at my different bases, and I want to make sure every base is represented. So my bases are, so ignoring the exponents right now. So my bases are, I have a 2, a 3, a 5, a 2, and a 3. Okay, so my bases, I have a 2, I have a 3, and I have a 5. Those are my different bases. The bases can be anywhere, can be in this or this. Doesn't matter, they can be in both, as long as every single base is represented. So I want to represent all my bases. So 2, 3, and 5. Okay. Then I'm going to write, so that's select all the different prime numbers. Then I'm going to write each prime with its highest exponent. So with the last one, we were looking for lowest exponent. This time, we're looking for the highest exponent. So the lowest common multiple, I'm going to look at my 2's. Here are my 2's. And I'm going to look for the highest exponent. So I have 2 to the 2, 2 to the 3. So the highest exponent is a 3. So I'm going to write 2 to the 3. Now I'm going to look at my 3's. So here are my 3's. I have 3 by itself, and I have a 3 to the 2. So 3 to the 2 is higher. And then 5, there's only one 5 and there's no exponent on it. Okay, then I'm going to multiply those together, making sure that I'm putting this into the calculator correctly. So 2 to the 3 times 3 to the 2 times 5, and I should get 360. That's the final answer for this question, 360. Okay, so the smallest common multiple of 60 and 72 is 360. Okay, next question. I have 3 numbers. So again, I'm going to start off by factoring those numbers. So I'm going to factor 35, and 35 ends in 5, so I'll take out a 5, and when I do, I'm left with a 7. Those are both prime numbers, so I'm done there. Then 60, we just did, so this time I'll do it like this: 2 and 30, 2 and 15, and 5 and 3. Just to show you a different way of doing it. And then we have 75. So 75, I'm going to start off taking out a 3. I mean, I could have taken out a 5 as well. And 25. And then that breaks down into 5 and 5. So I'm going to, let's make a big, so I'm going to write my, my number chains out here. I have 35 is equal to 5 times 7. Then I have 60 is equal to 2 to the 2, because we have 2 2's, times 3 times 5. And then I have 75 is equal to 3 times 5 squared. Okay, so now I'm going to look at my different bases. So I want to look at all these numbers and make sure each base is represented. So I have a 2, I also have a 3, I have 5, I have 7, so I'm going to make sure those are all written down. 2, 3, 5, 7. Is there anything else I missed? Just checking it over. No. So now for my lowest common multiple, I want the highest power of each. So I'm going to look for all my 2's. I only have this 2. So my highest power is 2 to the 2. Next, I'll look for 3's. So I have a 3 here and I have a 3 here. So times 3. None of them have a power. I'm going to look for all my 5's now. I have a 5, 5. Here I have a 5 to the 2. So that's the highest exponent. 5 to the 2. And then I just have 1 7 and it has no exponent. So now I'll multiply all those together and I get 2,100. And that is my final answer for that question. Okay. Remember, feel free to pause anytime you need, if you need to catch up on writing notes. And let me circle these and highlight them so they look the same. All right, there we go. Okay, so sometimes you have questions where they ask you to find both the greatest common factor and the least common multiple of a series of numbers. So for these questions, you're going to start off by factoring the same way, writing out your number chains. Then you're going to focus on doing the greatest common factor first, and then the least common multiple second. So let's look at this. So we have 14, we have 84, and we have 98. Actually, why don't you try factoring them, writing out your number chains, and then pause. So pause the video now, try factoring these and doing this. Okay, so factor and do this part, and then we'll go from there. Okay, so you've paused, you've factored this yourself. So I'm gonna quickly go through this. So 14 breaks down into 2 and 7. 84, you have 2, 42, 6, which is 2 and 3 and 7. And 98, you have 7, 14, 2, 7. So your chains, you get 14 is equal to 2 times 7. 84 is equal to 2 squared times 3 times 7. 98 is equal to 2 times 7 squared. Okay, so these are your 3 chains of numbers. This is what you should have gotten when you did your factoring. Okay, so the next step of this question, we have 2 things that we're looking for. We have the greatest common factor, remembering that that is the lowest power, and your plus, you want the common primes. And you have your least common multiple. So here we want highest power, and we want all the different bases. All the different bases. Okay, so using this as your number chain, again, now I want you to pause the video and I want you to find the greatest common factor and the lowest common multiple for 14, 84, and 98. So pause now and give it a try. All right, so I'm assuming that you gave that a try. So here we have, we want our common primes for our greatest common factor. So we're going to look for numbers that are in all the sets. So we have 2s and 7s. So for our greatest common factor, we want the lowest power. So we look at our set of 2s. We can see that it's 2 is the lowest power times 7. So that's 14 as our answer for our greatest common factor. For our least common multiple, we want to have all the different bases represented. So I'm just going to erase this highlighting. Oh no. There we go. And we want to list all of our different bases. So we know that we have the number 2. We also have the number 7. And we have the number 3. So we have 2 times 3 times 7. Those are all of our different bases. Now we need the highest power for each. So let's look at all of our 2s. Our highest power is 2 to the 2. We only have 1 3. And then we're going to look at all of our 7s. So all these. And our highest power is 7 to the 2. Then I multiply all of those together, and we get 588. So for this question, the greatest common factor was 14, and the least common multiple was 588. Okay. Now you're going to do question number 10, A to H, on page 20. And that's the end of this section, this 1.2. This week we'll also be working on section 1.3 as well.